All right, so on Friday, I went ahead and passed out our review, okay? The reason I did that was because this unit, when I was out, we got 2 days behind because I was out. And so because of that, we didn't get a chance to do as much practice as I wanted to. So I made the review a little bit longer to give us more practice on the different things. Your test will be on Thursday of this week, okay? We are going to finish the probability unit today with probability lesson 5, compound events, which isn't bad. And then we are going to have about 10 to 15 minutes to work on our review at the end of class today, okay? You are responsible for all of the even questions on your review. We're going to go over all of the odds. So you should have a full completed review by test day, so by Thursday, okay? I will have the full notes answer keys uploaded by the end of the day, and then that should let us have everything we need. And then I'll upload the odd questions, and I'll probably upload the answers to the even questions, just no work, so you can check them. And then the day of the test, ask any questions if you need to. Our test will be like 15 to 20 questions, but it's not that bad considering some of the questions are just like, what's the probability of this thing that you're either given in a table, or it's like of a dice or a dice roll or something like that. Remember, I am not giving formulas, okay? You are responsible for knowing your formulas, okay? The ones that you absolutely have to know are up there on the board, okay? You have like your probability of an event, just means favorable outcomes divided by total outcomes. You have OR probabilities, which you say the probability of A plus the probability of B minus the probability of A and B. You have conditional probabilities, which is the probability of A given B is equal to the probability of A and B divided by the probability of B. You have the independence formulas, and you have our compound probability formula, okay? So that is what you have to have. Yes?
On the test, do they have to list like what formula?
You do not have to list out the formula that you're using, okay? You just have to know it. But yeah. So, honestly, I would probably suggest at the beginning of the test, just like, I'll see if I can give like a little brain dump section so you can write down anything at the top of the test. But that is the plan as of right now. So our test will be on Thursday. Okay. Any questions about that or the review as of right now? All right, cool. We're going to go ahead and look at the probability of compound events. So when we're talking about the probability of a compound event, basically that's talking about the likelihood that 2 or more events happen together or in sequence. So if I want to say, what is the probability I draw a orange, then a white, then a white? Okay, that would be an example of a compound event. It's saying that not just one of the things happens, but all 3. What would be the probability that I roll a 5, then I roll a 4, then I roll a 3, and so on, right? So it's like multiple things happening together. So as we think of these, okay, we're not going to have to prove whether or not they are independent like we did last week on Friday. However, we are going to have to state whether or not they're independent, okay? Because being able to decide if they are independent or not will change how we do the problem. So if I have a coin and I flip the coin, okay, and the probability of it being heads, okay, now if I flip it again, does it change the probability of the second flip that the first one was heads? No, it doesn't say the same. So are those 2 events independent or dependent? Independent. Okay. Now, if I go back to this example, if I draw a orange, now, does me taking out this orange change the probability of me drawing another orange?
Yes.
Yes, it does. Okay. So, would that be independent or dependent? Dependent, because the next thing is dependent on what we already did. Okay, so that is kind of the difference. And most scenarios will make it pretty clear which work we're dealing with. And we'll talk about how to decipher it as well. So if we go ahead and look at the first example it gives us, it says, what is the probability of flipping a coin and getting heads, then flipping it again and getting tails? Okay, so how we write a compound probability is the probability of heads, then tails. Okay, so we're going to start with the probability of heads, then tails. Okay, and in order to calculate a compound probability, we take the probability of whatever we do first, so in this case, the probability of heads, and we're going to multiply that times the probability of the second thing. So we're going to do the probability of heads times the probability of tails. Then we're going to plug in any numbers we have. What is the probability of flipping a coin and getting heads? Times, what's the probability of getting tails? Now we multiply it together, okay? When we multiply fractions, we multiply straight across. What is 1 times 1? 1. What is 2 times 2? 4. So the probability of rolling heads and tails is 1 out of 4, okay? And if we think about what the sample space of this is, what would be the sample space for flipping 2 coins? I could do heads, heads. I could have heads, tails, tails, heads, tails, tails, right? That's the options. So how many of those are heads then tails? Out of 1/4, okay? And so we don't have to write out the full sample space if we know both of the pieces, okay? But that is how you write out a sample space. You list all possible options. Now, we're going to go ahead and look at the next example. So we roll a fair dice to find each probability. If we roll 1 dice, what is our sample space? Not 6, but it's 1, 2, 3, 4, 5, 6, right? It's all of the things 1 to 6. Okay, it doesn't ask us to write that, but we're going to just so we have it. How many things are in that sample space? So we have 6 total outcomes. If I roll a dice, does my first roll change my second roll? Are they independent or dependent? Independent, okay? So with these, same thing. So I have for number 1, we have the probability of 1, then 5. So we're going to find the probability of 3 times the probability of 5. What's the probability you roll a 3? Times, what's the probability you roll a 5? So what is 1 times 1? 6 times 6? So you have a 1 out of 36 chance of rolling a 3 then a 5. And that saves us from having to write out the full sample space of 2 dice and count how many times we'll roll a 3 then a 5. Okay, for number 2, probability you roll a 6 then a 6. So I want y'all to do that one on your own real quick. What's the probability you roll a 6 then a 6? 1 out of 36. Now we're going to look at number 3. So for number 3, we have the probability of rolling a 2 times the probability of rolling an odd number. What is the probability of rolling a 2? Times, what's the probability of rolling an odd number? Okay, what is 1 times 3? What is 6 times 6? Can I simplify that at all? To what? 1 over 12. Okay, so you can do it like that where you multiply everything, then simplify. Or you can look at the smaller fractions here and simplify first. I can't simplify 1/6, but I can simplify 3/6 to 1/2, which that just automatically gives me 1/12. I do not care how you go about your simplification. as long as you do it. Okay, you can go make it all put one together, then simplify, do it in pieces, use your calculator to help you simplify. I do not care. But what you have to have is you have to have this step and you have to have this step. Okay, this step can be done a few different ways, but you have to have these steps. Okay. Any questions about that? All right. Now we're going to look at the next example. So we have here a box contains 15 billiards balls, numbered 1 through 15. Okay. So basically we have all of these between 1 and 15 in a box. Okay, that's our sample space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So Betty draws a ball, records the number, and returns it to the box. So what's happening here is they take the box, pull out a ball, record the number, and then put it back. So after it's put back, does the probability change for what you're going to draw next time? So is it independent or dependent? Independent. Okay, that's the same thing that's happening here because it's getting returned to the box. That right there tells us it is independent. Okay, then Jill draws a ball. We're going to find some probabilities. So for number 4, what is the probability of drawing a 9 then a 3? So we're going to do the probability of 9 times the probability of 3. What's the probability of drawing a 9? 1 out of 15. What is the probability of drawing a 3? 1 out of 15. Then we multiply together. What is 1 times 1? 15 times 15. So the probability of drawing a 9 then a 3 is 1 out of 225. Pretty slim chances right there. Okay. Now we're going to look at number 5. For number 5, we're looking at the probability of 8, then a probability of an odd. So probability of 8 times the probability of an odd. What's the probability you're going to draw an 8? Times, what's the probability you're going to draw an odd number? 8 out of 15. So multiply straight across. 1 times 8 is? 15 times 15 is? And is there any simplification I can do there? All right, why don't y'all do number 6? How many evens are there? How many odds are there? So what's the probability of drawing an even? Out of? Probability of drawing an odd? And if you multiply those two together, what do you get? There we go. Okay. Now, for the next one, okay, this one has each letter of Littrell written on a card, okay? These cards are placed in a basket, okay? We're going to find the probability that if Martha selects a card, leaves it out, and then selects another card. So if she leaves it out, does it change the probability of what you're going to draw next?
Yes.
So that makes it dependent, okay? It is dependent. And that is because if you take out a letter, you're changing the total possible outcomes each time. So it is dependent because you are changing the total possible outcomes. So anytime our question tells us something about leaving something out, that means it's going to end up being dependent, okay? So if it says anything like this, okay, or if it does not say putting it back in, we're going to call it dependent. So we're going to look at some more of these too, but that'll help us. So let's go ahead and look at number 8, okay? So our sample space is LITTRELL. So if we are looking at problem 8, it says what is the probability of selecting a T, then an E? So probability of T, then E. So we're going to find the probability of T times the probability of E. That's still what we're doing. So if I look at this sample space, what is the probability of picking a T? 2 out of 8, okay? It is 2 out of 8 because there's 2 T's in there, okay? Then we know we pick a T, so we move one of those out, okay? So what does that leave us with the probability of selecting an E? It's 1 out of what? 7. Why is it 7 right there, not 8? Because we already took a T out, right? So we multiply this, okay? What is 2 times 1? What is 8 times 7? And can we simplify that? To what? All right, then we're going to look at number 9. Okay, for number 9, we still have our sample space. I'm going to put it right here. Okay, we have the probability of selecting a T, then another T. So we're going to do the probability of T times the probability of T. What is the probability for selecting the first T? What is the probability for selecting the second T? 1 out of 7. Okay, because when we select the first T, we take one of them out, so that only leaves 1 T left for us to choose from out of the 7 cards. So what is 2 times 1?
2.
What is 8 times 7? Which simplifies to? Now I want y'all to do number 9. Or number 10, my bad. What's the probability of selecting an E then an I? 1 in 56 chance. Okay. How do we feel about that so far? It's not very bad, is it? Okay. All we're doing is adding together probabilities we've already learned how to find. Or multiplying together probabilities we've already learned how to find. So we're going to flip over and we're going to look at some more examples. Okay, let's go ahead and look at number 11. So for number 11, Claire has a coin with heads on one side and tails on the other side. She's going to flip it in the air 3 times. What is the probability of the coin landing tails up on the first flip and heads up twice on the last 2 flips? So first, is that independent or dependent? Independent, because a coin flip is not changing each time, okay, right? And how would we know that? One flip doesn't affect the next. Even in my old age of 28, I still can't remember if it's effect or affect. I hate those 2 words. Effect is the effect something has.
The effect is before.
Yeah, and that, like, remember it because she told me, like, A is after something
Yeah.
happened, the effect after something happened.
And then E is like, how is it going to happen? Yeah.
So,
It-
it's fine.
all right. So we have to do the probability of tails, then heads, then heads. So how many different probabilities are we going to have to multiply together there? 3. So we're going to do the probability of heads times the probability of tail. Oh, wait, I got that backwards. Tails times the probability of heads times the probability of heads. What is the probability of tails? What's the probability of heads? What's the probability of heads?
1/2.
What is 1/2 times 1/2 times 1/2? 1/8. Yeah.
I was gonna say.
Okay, now we're good for number 13. So for number 13, Tim's golf bag contains 9 white golf balls, 6 yellow golf balls, 1 orange golf ball, and 1 pink golf ball. Okay, so how many total golf balls does Tim have? 17. Okay, and it says without looking, Tim is going to take 1 golf ball out of his bag to tee off with, and then a different ball to putt with. Okay, does that say he is putting the ball back in between? So is that independent or dependent? Dependent, because whatever ball he picks first is going to change our probability. Okay, so what is the probability of Tim teeing off with a white ball and putting with an orange ball? So we're going to do the probability of white, then orange. So what do I need to find? Then what do we need to do? What is the probability of a white ball? 17. Okay, then what's the probability of an orange ball? 1 out of 16. Because it doesn't say he puts it back. So we're just assuming he's taking 1, then grabbing another. Okay. So what is 9 times 1? 16 times 17? 272. We ready for 15? Okay. So a drawer contains 10 blue pens and 10 red pens. Without looking, Mr. Wells is going to take 1 pen from the drawer, use it, then put it back in the drawer. Since he's putting it back in the drawer, what does that automatically tell us it's going to be? Right? Then he is going to take another pen from the drawer to use. What is the probability of Mr. Wells taking a red pen first, then taking a blue? So we're looking at the probability of red, then blue. So y'all go ahead and do that one for me. Okay, what is the probability of picking red then blue? 1/4. Okay, because we could either take 10 over 20 and multiply it by 10 over 20 to get 100 over 400, which then we simplify, or we could simplify both of those to 1/2 and do 1/2 times 1/2, which is 1/4. Either way works. For number 17, okay, There are 5 slices of pepperoni pizza, 1 slice of sausage pizza, and 3 slices of cheese pizza left. Without looking, Mr. M takes a slice of pizza, ate it, then took another slice. What is the probability of Mr. M eating 2 slices of cheese pizza? First off, is that independent or dependent? Dependent. Okay, it is dependent. Why? So once he eats it, there's no getting that pizza back. And if there is, you don't want it. Okay, so we're going to figure out the probability of eating cheese, then another cheese. So what's the probability of the first cheese? 3/9. Okay. Then what's the probability of the second cheese? 2/8. Because not only are you taking a slice of pizza, you're specifically taking a slice of cheese pizza. Whenever it is dependent, especially the number on the bottom is going to go down. The top number on top, it depends on what the question's asking. But the number on bottom will always go down if it's dependent. Okay. So we could do this, I'm going to do this the other way. What can I simplify 3/9 to? What could I simplify 2/8 to? And if we multiply 1/3 and 1/4 together, we get 1/12. We could do it that way. Or we could have done it 3 times 2 is 6. 9 times 8 is 72. And then simplified it. Both ways we get the same answer. It does not matter which way you do. Okay. Our last page for today, okay, is there are 12 pieces of candy in a bowl. There are 6 mints, 4 butterscotch, and 2 cinnamon candies. Okay? So each of these questions has to do with that specific sample set. Okay? Or that sample space. So we're going to start with number 19. What is the probability of Mr. B pulling a butterscotch from the bowl, putting it back, and then choosing a mint? Independent or dependent? Independent, because of the putting it back part. So we have the probability of butterscotch times the probability of mint. So we get, what is the probability of choosing butterscotch? 4 out of... Times, what's the probability of choosing a mint?
6.
So what would that equal? 24 over 144, which simplifies to? 1/6. All right, and we're going to do the odds together, and I'm going to let y'all do the evens. Okay? So for 21, what is the probability of Miss H choosing butterscotch, keeping it, then choosing cinnamon? Independent or dependent? Dependent, because she keeps it. So we're going to do the probability of butterscotch times the probability of cinnamon. What is the probability she chooses butterscotch? What's the probability she then chooses a cinnamon? 2 out of 11, because it is dependent. Okay, when it's dependent, the bottom number has to go down. The top only goes down if it's the same thing both times. But because if instead of drawing a cinnamon, if she would have drew another butterscotch, what would the top number have been? Instead of 4, it would have went down to 3. Okay. And that gives us 8 out of 132, which is the same thing as 2/33. Okay, for number 23. Mr. B chooses a mint, replaces it, chooses a cinnamon, replaces it, then chooses a butterscotch. Independent or dependent? Okay, so when we do this, we're going to have the probability of a mint times the probability of cinnamon times the probability of butterscotch. What's the probability he picks a mint? What's the probability he picks a cinnamon? times what's the probability of butterscotch? Okay. And what would that be as a fraction?
48.
Which simplifies to 1 out of 36. We could have also done that by doing 1/2 times 1/6 times 1/3. All right, for number 25. What is the probability Miss G flips a coin, gets tails, chooses a candy, gets mint, rolls a number, gets 3? So, do any of those things have anything to do with the other ones? Independent or dependent? Independent. Because your coin flip has nothing to do with your dice roll, and it has nothing to do with the type of candy you grab. Okay? So, the probability of a tails times the probability of getting mint times the probability of rolling a 3. Okay? And what I would set that up first is the probability of tails, then mint, then rolling a 3. All right. What is the probability you get tails? What is the probability you get mint? What's the probability you roll and get a 3? All right. So, what is that going to equal? 1 over 24. Because if you multiply that all together, you get 6 over 144, which simplifies to 1/24. All right. I want you to do 20, 22, 24, and 26. Yes. And I will post the answers up here so you can check them. Okay, and once you are done with these 4, you can spend the rest of class working on y'all's review. If you have any questions, you let me know.